Technologies. We did consulting on the design with Rock Paper Sun on the install here. It's kind of an interesting story here in terms of what WSE does. We've mainly come from working out small 12-volt off-grid applications to out east. I don't know if anyone's familiar with the Ontario microfit program, and now coming back to Saskatchewan here and doing the Saskatchewan net metering program and working with Fair-Eco. So start off here. Quick system overview. As you guys can see, panels on the outside of the house here. We've got 240 watt off-sun panels. There is 2 strings of 9 panels mounted on the Hadicon railing system, and we've got a Keiko inverter 2005. So it's somewhat oversized for the amount of panels that are there. So there is some room for growth in the future. If panels were to come down, or Ron was to find some more space for panels and a greater need for electricity. So the PV technology that we have on here is the off-sun panels, as I stated before. It's also a monocrystalline panel, which is the most efficient panel on the market. It does come into effect when you're looking at the sizes of roofs. So on this project here, we're actually maxed out the roof size in terms of how many panels that we could put on the roof. So if you're to put on a less efficient panel, such as a polycrystalline or a thin film, you're going to require more roof area for the same amount of production. So it makes it a little more a concern. Smaller roofs, you have limited south-facing exposure. So the grid-tied PV technology is a lot of people have asked, one, is the battery banks there? These systems are set up basically to feed back into the grid, as the name implies. Basically, they're running off the roof into a combiner box here to disconnect more for a safety, to work on it, as well as to make sure that if the local utility wants to shut the system down, they can. Then we're going to our inverter, which is converting it from our DC load to our AC load, and then this is going back into a meter. So the cost of installing PV, this is where we get into the fun questions. So how do we value the renewable energy systems that we put onto our houses is often a big question. You can look at it from kind of a tit and tat system, or you can really sit down and look at the true cost of the system and how you value that energy to you from maybe a social or moral standpoint. So the question just to think about as we go through this is, why would you want to buy an alternative energy system? For the system that we have here, we're seeing costs anywhere from about $7.50 to $10 a watt, and that's an install price. It's not a panel price. It's as we see it here. The price of a panel is obviously going to be a lower price. So what we quote is an install price. So for this system here, it comes out to about $33,000. Under that net metering program administered by SRC, the whole system is eligible for a 35% grant or rebate. So our system here comes out to around $20,798. So our system being 4,410 watts will provide around 6,171 kilowatts a year. Value at the current price around 11 cents a kilowatt, the value being $678 a year produced in energy. I like to talk to my customers from that cost that we did on the last page of about $20,000 to the power generated at $678. I'm sure a lot of you would kind of wonder why you would go into that endeavor. Flipping back to that last page is how do you value the energy coming into you from one of these systems? Other scenarios I like to talk about is if Saskatchewan had the option to buy green power, what would the premium be on that price? I've been told around 20 cents is a good, or 20% is a good premium price for green power. So that would bring us up to about 13 cents a kilowatt hour. engineers told me, maybe a better way to look at it would be to take your amount of energy used from your household and divide it by your whole bill, because you're starting to consider your service fees and all those, which are fixed costs, and they're going up. Other ways to look at it is to calculate the inflation, or if you look at SAS Power, they admit electricity will increase about 8% a year for the next decade. So when you're looking at the cost and getting back to that $678, obviously that's in this this year. Over the next 10 years, or the lifetime of the system, that's going to be an increasing energy cost. I'm not an accountant, but what actually Ron here told us was that we can look at the net present value of the system, what it's worth over the lifetime and how much it can generate, and extrapolate that into the value in your system. So, is there any questions on that? This one can be a bit about 25 years. A lot of them will be rated around 20 years for the same 80% output. So what they actually warranty is the output of the panels as well as the lifetime. So at 25 years, the panels may still be working, but the output may be lower than specified.
Is there any maintenance on the panels?
The system, not to my knowledge. There's not a huge, obviously, washing the panels like here. During the installation, dusty parking lot, we noticed quite a bit of dust build up over the first little while. Luckily, as soon as it started raining, it was all cleaned up. But other than that, there is no maintenance on the system.
Do you generate a lot more power in the summer than in the winter?
Yes, just from strict extra daylight.
Are they insurable? No, the reason I ask is I'm thinking of hail. Because we live in the prairies, so I mean we can get severe weather and hail. So are they insurable?
That's a very good question. I'm not sure. You gentlemen might know.
So I have a PV system on my house, and I talked to my insurance broker about it, and he was happy to increase my insurance premium to cover the added value of the panels. Now, if we get a hailstorm and they get wiped out, whether he'll pay. But he seemed to think so. He said it was similar to a skylight or something like that.
Oh,
It becomes physically part of your structure.
Yeah, very good question. Just quick notes on that last slide there.
And then my second question is, this slideshow, is it available on the website?
It is not. I'm not sure if you guys are making.
No, we can look into it. What our current plan is to post the videos about a week afterwards on YouTube.
You can also contact us at WSE. I'm sure we can get some out to you. Just a quick, I basically doubled the price of electricity to 20 cents a kilowatt. And this is, all this stuff here is using a program. It's called PV Watts. It's readily available online. It comes out of the States, so you can actually plug in the size of your array, tilt angle, and price of electricity. So just threw a few numbers in there. At 20 cents, the amount of energy that it produces and the value at 20 cents is 1,234. And at the 15 cents a kilowatt, it's about $925 a year. And one thing with these net zeros, I guess, to realize that that service charge is never gonna, your use and your production may zero, but your bill for service charges will always remain there.
Is that a standard rate for everybody, the service charge, or what?
I'm not sure. I'm sure it differs for commercial to residential.
So that you're just basically paying for the use of their meter?
And as I guess too, as our metering systems and smart grids expand, it's something that will increase the cost of your service. I mean, we really are looking at redoing our grids, especially down in the States where a lot of this technology is coming out. It's essentially rejigging the grid, and there's a cost to that. So I mean, going out of the cost of PV and how we relate to it, I just wanted to use a net zero house because it's great in that the production of electricity here, and the way Ron and Dr. Rob Dumont have designed the house is that they want the energy consumption of this house obviously to zero out. This house is strictly electrical.